All right, welcome to episode 2, everybody. In this episode, I'm going to show you how to actually make our very first script. We're going to get this box moving, our player. Again, we haven't brought in any artwork yet, so let's start with selecting our player. And we're going to scroll down in the inspector. At the very bottom, there'll always be a button called Add Component. So we're going to add that, and we're going to make our first script. Okay, so I just start typing script, and we see new script here. We're going to select that, and we're going to call this player and then controller. Now notice how I'm naming this. Okay, capital letter on player, and then no space, capital letter on controller. This is how we're going to be naming things when it comes to our scripts and other objects or materials that we're going to be creating. So we're going to create and add. So now I have a script added right here. It's called player controller, and we're going to edit it. And the way we do that is we're just going to be double clicking on it right here. Oh, it's just loading. And it's going to open up with something called Visual Studio. So Microsoft Visual Studio is what we're going to be using to implement our code in our game. Give this a second to boot up. And it's going to be overwhelming at first, but don't worry, I'm going to help break this down bit by bit to make it a lot easier. Okay, I'm just going to make sure I have two of these open right now, so I should close one of them. Make it not so confusing. There we go. Okay, so let's talk about this very briefly, and then we're going to do some simple coding to actually be able to move our character left and right in this video, and we'll do a few tweaks in Unity. So in Microsoft, in Visual Studio here, your default, every time you make a script, it'll start with these 3 using statements. I'll explain that in a second. And then it's going to have the public class and whatever you named it, which we called ours the player controller. And it's using mono behavior. And for now, it only has inside this class, which is contained in curly braces, 2 different functions. We have something called the start method, a method or function, I should say, and the update method. So the language that Unity uses, coding language, is called C#. And so, whereas other languages, they're usually called functions, in C#, they're called methods, so there's kind of interchangeable. And this is where we're going to control things. So what's going on here? Let's break this down. So on the left, we have each line of code being tracked over here. The 3 using statements, think of these like libraries of different tools that we can use, different functions or methods that exist by default in these libraries. So sometimes we're going to actually add an extra library of stuff to use, but these 3 will cover most of what we're doing. Then inside of our class, this is where we must contain all of our code. What do we want to happen on this script? Okay. And it's going to default with these 2 functions. So the start, it says start is called before the first frame. Now you notice this is in green, and anytime you want to write a description or comment, it's called, we can do a double / and I can type hello, how are you? Right? So anything I type here is not going to affect my code. It's more talking to the coder or the people reading your code what is going on. So comments are a really good practice to explain what your code does. So the start function, this will start at the very beginning of the first frame. Okay, so if this script is on our player, this will run 1 time. Whatever's in this block of code between these curly braces will run once. Okay, down here we have what's called the update function, and this runs every single frame. So if your computer's running at 30 frames per second, kind of slow, this is going to run all this code 30 times per second. But if it's running at 60 or 120, it's going to run all this code 60 or 120 times per second. So this is where we're going to be putting in a lot of the action, so to speak, especially our inputs from the player. Okay, so let's do something in here. So before we do anything inside these functions, we're going to create some variables. Now, the most common variables that we are going to use are numbers and true and false and text. Those are kind of the most common. And we're going to be making them either public, or sometimes we're going to be making them what's called private. And sorry, you can't really see that right now. Public versus private. So what this means, when something's public, when I create things public, I'll be able to modify their values in Unity. I'll be able to modify them over here. You'll see this shortly. When they're private, I can't see them or modify them in Unity. And sometimes we want to see stuff and modify them, and sometimes we don't. So we'll go back to Visual Studio here, and we're going to create, I'm going to keep it public for now, just so you can see what it looks like. We're going to create something called a float. Now, the other most common variables that we're going to be using is int, which is an integer, negative or positive integers. We could put in a string, which is string. This is just text. We could be putting in a bool, which is a boolean. This is a true or false variable. These are the most common ones we're going to use. Float is just a decimal. So we're going to be using a public float value here. And then when you declare, I want it public, it's going to be a float. What's the name of this variable? Think of it like an empty basket. I got to put a name on this basket before I put numbers in it. This is going to be our move input. Okay? And then I put a semicolon at the end of a line of code. So this is declared. I have a new variable called move input. All right, then we are going to need one more thing. We're going to need a public, and we're going to be referencing the rigid body because we're going to be applying forces to it. So we need to reference it as one of the components. So I'm going to type in rigid body, and you notice we have this, I'm using my arrow keys, it's automatically this is the assembly C#. It's also called IntelliSense. It's kind of like your autocorrect when you're typing in your phone. I can just press tab and it quickly types the rigid body 2D, so then I don't make any silly mistakes. And a common name for rigid bodies is just RB. So I'm just going to call that RB for short. Okay, and then that's all we're going to do for now. We're going to go down now into the update, and we're going to collect that input. So every time we want to check, we want to set this move input every single frame. So how do we do that? Well, I'm going to take our variable move input. I'm going to type that in, and I want to get it from the player input. So we're going to collect some player input. So now the update's going to check if a certain key was pressed. So we're going to go input dot get access raw. That's the one we want. Okay, and we're going to call this, and we have to type this perfectly. We want to get the axis that is the horizontal. Okay, so make sure you type that perfectly or else this isn't going to work. So what is this actually doing? It looks like a lot. So input is a method that I'm calling to then use the getAccessRaw method, and it's going to collect the default horizontal input, which is your arrow keys, or if it was a game controller, your thumbstick going left and right. This is going to get our input. Now, that returns a number between -1 if I'm going left and +1 if I'm going right. If I do raw, there's no decimal approximations in between, which is what we want for snappy movement. But get access would work. It would just be a little sluggish when we're moving our character. So now we've collected the input, and it's going to store it in the move input variable every single frame. Okay, so when I'm pressing the right arrow key, it's going to give me a +1. If I'm doing left, it'll give me a -1. Now, what are we going to actually do with that? Well, we're going to actually open up a brand new method called the void fixed update. So notice I just started to type, I'll do that one more time because that was fast. I just started to type void because I'm not returning anything. Void means nothing. I'm returning nothing. And then I started to write fixed, and then as soon as I saw fixed update here highlighted, I pressed tab, and it instantly creates the method with the curly braces to control to give me access to the code. Okay, so now let's use this move input. What are we going to do? So we're going to now access the rigid body, RB, and then we're going to change its velocity. So the RB dot, I'm going to access its velocity, and we're going to set it equal to what's called a new vector 2. Okay, vector 2 because we're in 2 dimensions. It would be vector 3 if we were in a 3D game. So we're going to set up a new vector 2. A vector stores 2 floats. Those 2 floats are the x value and the y value. So we have 2 directions where we can have velocity, left, right, and up, down. Now we can combine those and you get a diagonal of some kind. So we're going to add that right now. And the autocorrect actually kind of knows exactly what I want it to do. I want to do the move input. And I just want to set the RB.velocity. I should explain that. Okay, so the first I'm putting in 2, you can see here float, I need the float x and the float y. So the float x is going to be my move input, and then the float y is going to be whatever my current y is. Now we haven't implemented a jump yet, so I just want to basically, whatever is the current up and down or y velocity, I want to keep that the same. Okay, this is going to work. This is going to allow us to move our character. So let's press Control S. Okay, and so just to show you what happens there, if I type something, up here there is an asterisk. That means it's not saved. And none of your code will be applied to your video game until you save the script. So Control S is the shortcut. That little star goes away. Let's go back to Unity and see what happens. I already know we're going to have some issues, but that's where we're going to do some learning. So once the scripts reload, we're going to game test. And let's see if I can actually move my character. But I want to show you down here, I now have the player controller and I have a move input. Remember, I set these 2 things up as public. And so that's why we can see them in the script. All right, now I'm going to save us one mistake. And you can see that the RB, remember I said we have to reference the rigid body? It says none currently. This is easy. I'm just going to click the rigid body that is on this game object, our player, and reference it. Okay, so now it can apply forces, velocity changes, to my rigid body. So let's test this out. Let's press play. And I'm just going to be using my arrow key. I'm going to go over here, click, my box should fall down. And if I use my arrow key, I roll to the left and I roll to the right. Okay, and we can zoom in on the scene view here and I can see a little bit more of what's happening. Why am I rolling, you might be wondering? Well, remember, because we put a capsule collider, looks like a circle. So everything's kind of rolling. So we have a few issues to fix, and also this is extremely slow. So we're going to tweak a few things, but we have movement, it's just not good movement. So let's get out of here and let's make some tweaks. First of all, I'm going to go on my player, I'm going to select the rigid body, and I don't want it to roll and rotate like that. Kind of looks cool, but we don't want that. So I'm going to go to the rigid body here, and down here we have a tab called Constraints. And the constraint I want to set is I want to freeze the rotation on the Z. I don't want it to rotate at all. So I'm going to click that button right now. Okay. Also, the other thing we noticed was it was really slow. So it'd be nice if I could control the speed at which I moved. That would make a lot of sense. So let's go back to our script. We're going to go back up here and we're going to make another variable. So I'm going to press enter. I'm going to call it public float, and we're going to call it, well, we'll use exactly what the default is saying. We're going to call it move speed. So let's go down here now. This move speed, I could set its value right now for its default. Let's set it to 5. So I'm going to go equals 5, and I have to put an F at the end because it's a float. So make sure you do that. Unless it was a decimal like 0.03, it'd be okay. But let's make sure we put that F after. And then down below here, we're going to take move input, and I'm going to multiply with the asterisk symbol by the move speed. Oh, not move input, move speed. Okay. And you notice if I type something wrong, it's going to get a red underline because it doesn't recognize it. It says it does not exist in the current context. So we have to make sure we spell things perfectly. So Control S now. Make sure your code matches mine perfectly. Let's go back into Unity. And you're going to notice we're going to get a move speed variable here on our player controller script. There it is. And it's defaulted to 5. Now, let's test this. Let's see what we think. I have no idea if that speed's a good speed. Let's find out. So there we are. Now I can move left. I can move right. Let's zoom out a little bit so I can see it from the director's point of view versus the camera. Okay. So this is kind of slow. So now I can kind of figure out, okay, I don't really like this speed. Let's try and move it up to 10. Now if I move this up to 10, it'll work. Now I'm double the speed, but if I get out of play mode, see this little play is highlighted blue, it will not save my changes. So it's great to live test. I do like this 10. I think I'm going to keep it at 10. So I'm going to click get out of play mode. It's going to go back to 5, notice that. But now I can hard set it to 10. Doesn't matter if I hard code it to 5. I've set it in my inspector to 10, so now it's going to stay at 10. Okay? All right. So I'm going to Control S, save that, and we're going to do 2 more tweaks because right now our camera doesn't move with our player, and our player is dead center. And when we make this game, we actually want our player off center. So I'm going to show you one more thing here before we end this video, and it's really easy. It's called childing. So when I want a game object to stay attached to another game object, I want the camera to follow the player. It's called childing. So I'm going to select my camera and I'm going to child it to the player. So now once I've childed it to my player, if I go in here and I move my player, it moves my camera automatically. If you can see that, see the camera right there? It's kind of the same color, but you can see in my game view that the camera's following my player. I'm just going to set that back to where it was at 0, 0. And then I want to create an offset though. So I am going to move the camera slightly over to the right. And you see now I have this offset. I'm going to set my offset to about 5. And now we have our player to the left, which is pretty normal for Geometry Dash style game. That's going to be a side scroller. Our player is going to be off center to the left. And now if I press Game Test, I'll have a 10 speed and the camera will follow my player. Here we go. I can move left and right. Careful, there's an edge there. And of course, if I fall off into oblivion, I just fall forever. And that's not going to get us anywhere. Okay, so that concludes this video. We now have basic movement left and right by modifying the rigid body. And we've done a quick edit on the camera to become a child of my player. So my camera automatically goes where my player goes. All right, that's it. That's all. We'll see you in episode 3.